is going to be recorded, so if people want to come back later and listen to it, they certainly can. Andrew, I'll leave it to you now. I've still got a minute or so before the hour.
Well, good morning. This is 8 o'clock in San Francisco, and we're opening up the third of the sessions for real-world performance to talk about the video series and generally just talk about real-world performance as a subject. We have these chats, and I have a very much less structured session today because I really wanted to get questions from the people out there in the real world, and just be a little bit more provocative and share some ideas and share some of the activities my team has been doing in the last 2 weeks to reinforce a lot of the things that are going on, that we're documenting and attempting to educate and show in the real world video series, just to show that you know, whilst you might see this in a video series and not believe it exists, we actually do see it on a daily basis. And so I'm going to be a little bit provocative today and perhaps tease a few people, which is not unknown for my team to do such a thing. And really what we want to do is get a bit of a dialogue. I'll be monitoring the chats, and so if you have questions and things like that, I'll be really keen to see them. And, you know, we're just going to go through the topics little bit by bit, and hopefully you know, I'd like to sort of make these events a little bit more interactive rather than one-way traffic, and hopefully we can do some good stuff and share some good ideas. As I say, I really like to see it a bit more two-way traffic, and perhaps we can provoke some ideas. So just for those that have come onto these sessions for the first time, and I do apologize if people have sat through the other sessions. My name is Andrew Holdsworth. I've been at Oracle what it seems like forever. It's not been my entire career, but a great chunk of my career. And I run the real world performance team in database development. We're kind of focused at the sort of performance as experienced in the real world, actually, you know, not esoteric or academic performance, just practical real-world performance. And you know, I have in the process of as we do real-world performance days and education, and when people ask me to talk about it, you know, I've come up with some fairly basic tenets of what contributes to good performance and the behavior of people trying to get good performance and the way they work. And one of the things I can really say is that good performance is rarely an accident. People don't suddenly land with good performance on their system. It's usually a result of some people thinking ahead, getting ahead of the curve, and designing performance pretty much and architecting it into the solution. The number of times that poor performance is associated with a philosophy to retrofit performance after the functional code has been done is unbelievable. So, you know, performance is not an accident. It rarely is an accident, and if initial performance is good by luck, it rarely stays that way as the system gets to scale up. Something I was also taught a long time in my junior career is after getting extremely frustrated with a client who seemed to make the wrong decisions at every point in time of the project at an engineering level, people get the systems they deserve. If they don't apply the effort in the right places, that lack of effort is rewarded by poor performance, poor reliability, and frustration. And it really is a function of you get what you deserve in the end. If you embrace a technology that is immature and you don't know how to use it and don't understand it, it will be a high risk project. And then the last thing is something that we're seeing a lot in performance, where people are saying things are good enough, or it's good enough to support the business. My experience that good enough is a cop-out. It rarely is. It's not good enough next week. And so really we need to refocus our efforts in terms of performance engineers to focus on excellence and efficiency and getting the best out of the software and the hardware available to you. And this sort of a philosophy very often puts us at odds with the MBA types who do performance by MBA, and we'll talk about that a little bit later. Again, I'll repeat, we basically now break down real-world performance projects into sort of three categories. In terms of when we see a performance problem, we box the issues. And one of the first ones what we see is incorrect use of the tools and the products. It sounds the most obvious thing is that if you use the products correctly and in the manner they were meant to be designed, they would perform for you. Unfortunately, the products aren't used correctly a lot of the time, and so performance suffers. The second issue is the big data, little data challenge. Really, this is a legacy, particularly in the Oracle space, where people grew up learning how to code OLTP and operational systems, where the biggest amount of data that you actually ever dealt with in a piece of application code was the amount of data on a screen, which was pretty trivial. But of course, now we're doing analytical programs where we may be required to profile terabytes of data. And of course, the algorithms for dealing with a large data set efficiently compared to dealing with a few rows are fundamentally different. And if we don't make that understanding and we don't brief our architects, haven't got a grasp of it, and the developers and programmers haven't got a grasp of it, they'll just go back to what they know. So an Oracle programmer that has spent their whole time building OLTP systems will basically write the same sort of code and the constructs to deal with millions of rows as they would with 10 rows. Unfortunately, it's not a good way to go forward, and we're doing more education on this. And then the last stuff is just dealing with the legacy of debugging systems people try to improve performance. And certainly in America, I hear this term whack-a-mole, which is something I don't really understand because I'm being English, but people basically just trying to whack the symptoms out of sight and then just jumping from fixing symptom to symptom to symptom, and very often putting things in place, but they really never knew what caused all the symptoms and never knew the problem. And so we see this a lot, this moving to a solution phase before people have actually got to the point that they actually figured out what the problem is. And a lot of this is just busy work, being seen to do something, to solve something because we saw a symptom, but not really getting to the root cause of the symptom. And very often this is a function of always being in a continual rush and not being able to think, but it's really not an excuse, because the big gains come in performance work from understanding what the problem are and getting the appropriate solution. Okay, so the video is released this week. You'll notice we put some more on, complete out the set best process programming, and that's we're going to talk a little bit more about that, and then I'm going to talk about what's been going on in real-world performance. And so, completing the set-based programming, and I reinforce what we spoke about last time. Very often we see programmers thinking row by row or object by object type processing because it's kind of easy. We call it slow by slow processing, and you've just got to start thinking about analogies in life. If you were to had a requirement to load and validate and manipulate 10 million rows, would you load, validate, and manipulate 10 million rows all in one go, or would you load, validate, and manipulate one row and call it in a tight loop 10 million times? It sounds very easy to say that, but if we go back and look at a lot of our applications, we find that we write a method to do it for one row and then call it in a tight loop. And it's inherently slow. Although you may actually make the code to operate on one row extremely efficient, the multiplier of a big number times a small number still relates to a big number. And by adopting a set-based technique where we do using bulk techniques, and the demos will show different ways of achieving bulk or set processing, stepping through from no set-based processing to just using bulk access methods for the database, homegrown parallelism for the people dividing that up, and then just using core parallelism within the database, which should be your panacea to move to. This is very often the problem we see in these long-running batch jobs when people tell me that they've got a batch problem that's going to run for 9 hours and things like that. And as a result, it's because it's using one CPU and it's just running serially. So, in terms of just trying to look at some of the multipliers, you can see that if we're doing a millisecond per row process, as we bounce through to 1 million, 1 billion, and 1 trillion rows, and we have a serial process, when we get to 1 trillion rows, it's not going to happen in your or my career. It's just going to take too long. And so we need to start doing alternative programming techniques to just break out of this sort of serial row by row or object technique. However, what we do actually see a lot of people try to do is create multiple threads of activity, then doing a row by row programming. And what this tends to have an effect is there's still thousands or some multiple orders of magnitude off on the CPU costs, but then suddenly these multiple threads of single row programming start contending with each other through indexes and things in the shared pool and the buffer cache, and so they don't scale very well. And so really we need to try and encourage people to write true set-based programming techniques, and we show those in the demos, to exploit the core parallelism within the database of a SQL statement rather than just running multiple SQL statements in parallel from the application. So a lot of food for thought. It's done as a race mechanism where we race the demos off against each other and we can see who's going fastest. And with that in mind, just look at them and then start prototyping yourself, and start doing some goal setting. If we've got a 9-hour batch job, let's try and get our heads around running them in as a set-based program, build a prototype, and see how quickly you can make it execute. It's all good, interesting stuff. And, your efforts are usually rewarded by multiple orders of magnitude performance increase. And then you become the expert, and that becomes even more interesting. So what's really been going on in real-world performance recently? Well, it's been quite interesting in terms of the last time. We've had a couple of escalations and incidents that came to us, which are fundamentally the same problem associated with high concurrency applications, OLTP mixed with batch systems, and they basically all showed the same fundamentals. When the system was not being that busy, they showed plenty good performance. There was not a performance issue. However, the systems had acquired reputations for being notoriously unreliable and falling over and appearing to hang, and had, in many cases, had to be restarted. And these systems had all basically suffered from a sort of bottom-up debugging approach, where people had looked at the symptoms of what was happening when the performance was poor and tried to fix the symptoms rather than look at the root cause of it. Now, the root cause of it was written on the first page of the AWR report, which is, if you look at the amount of CPU seconds burnt per second, and when that number approaches or exceeds the number of cores on the system, you basically have oversubscribed the CPUs and the box is out of gas. And as soon as we get into the situation where we get into CPU oversubscription, we get into a queuing situation and a diminished law of diminishing returns. And so we start seeing the database starting to stall, and we start seeing well-known parts of the database showing up as statistics in the AWR report. What we start to see is extension of log file sync. The actual log file writes hadn't increased in much time, but the writes were going through quickly, but the log file syncs were increasing because it was becoming increasingly harder to schedule the process after it had been put in a wait state, waiting for a commit. Likewise, when we see oversubscription, we tend to see the latches and the mutexes in the shared pool all tend to have a habit of increasing and increasing and increasing and getting worse. Now, the reason it gets even worse is when we have an latch and a mutex, if we can't acquire that resource, we tend to spin and burn more CPU cycles. Now, spinning and burning more CPU cycles on an oversubscribed system puts you on the sort of law of diminishing returns. So it was quite interesting to see these things, and yet all the same mistakes had been made in terms of people who have been filing SRs, something wrong with latches, something about log file syncs, and trying to blame the I/O subsystem. And in fact, there was nothing wrong with it at all. It was just a straight CPU oversubscription problem. And people were just victims of bottom-up debugging and overprocessed. And it was quite ironic. On one of the sites, we saw a number of SQL statements that were running on the system that had burnt over 1,000 CPU seconds, and those were the ones just finishing in the AWR report. I dread to think how many had not even finished within that hour, such that we didn't even get a statistic on this. Other things that mitigate this have led to this point was that people were kind of in denial that they were actually overprocessed because they were looking at the CPU. They weren't looking at core utilization at the operating system. They were looking at thread utilization, and thread utilization is not core utilization. So they basically had a conflict between what was going on in the AWR report and what they perceived the operating system statistics. So we've been seeing quite a few of these things. It's funny how these things come up in threes, and literally we've had 3 in the last few days. And it really has been a case of too much bottom-up debugging and no one looking at the big picture and recognizing if you're oversubscribed, you're going to see a lot of symptoms. And we've showed this in some of the video demos, and with those that have been to our training classes or real-world performance days, we've demonstrated oversubscription and what actually happens to the system as it degrades. So it really does happen in the real world, but it does take, when you get landed with these things, a large amount of clarity and ability to articulate to the people what is going wrong with the system. And again, this leads us into it. Everybody at this point is always looking to you for some magic button or silver bullet that you can press, or some alpha bit to be set to make everything perfect. Now, in these cases of CPU oversubscription, there really is not much magic to it. It's take the load off the system. So workload management, potential of resource management and governing of processes, or the real hard work, go and look at what's burning the CPU and increase its efficiency. Again, nobody really wants to get into the hard work, they just want some magic bit to press. And we never said that real world performance was easy. It's always hard work. It's getting the data and affecting the numbers. And so if the CPU is getting burnt, find out what's burning it and eliminate it, or schedule it when the system is less busy, such that we don't oversubscribe the system. One of the simplest ways to deal with it. But again, I don't see many people standing up and trying to do this. It tends to be like, oh, well, let's try some more patches and fiddle with some parameters, and hopefully it'll get better. Again, it's the tuning by hope again, not tuning by numbers. What we have also noticed over the last couple of weeks is the list of excuses for tolerating or going slow just gets longer and longer. And it comes back to what I said in the last session. Really, as a performance engineer, you are a change agent. You are there to initiate change in your organization, initiate change in code, initiate change in setup of systems, to change the performance profile of the system. However, humans being humans, and we all have our own little fiefdoms and turf and these sort of things, we find some incredibly good excuses, both technical, organizational, political, for actually not doing anything and tolerating poor performance. And probably one of the most common ones we've seen on one project is this tolerance of just basically not gathering the statistics correctly on your data. And in many cases, they're using the same stats gathering mechanisms that they used in version 7 and 8 and sample sizes, and haven't upgraded to use auto sample sizes and gather the statistics correctly. And in many cases, we've showed orders of magnitude improvement because suddenly when we're getting good cardinality estimates, we get good execution plans, and we're getting things go a lot faster. But there's always somebody in the back room saying, oh, we tried this 3 years ago and we found a bug and one SQL statement regressed, and so therefore these things don't count. It really is a case if you've got to keep up, okay, and use the products as they were designed. They are an evolving thing. Yes, there probably will be a few SQL plan regressions, but again, if you're a good real-world performance engineer, you'll be able to get to the teeth of them, figure out why they regressed, and basically allow yourself to adapt. Again, there's just a lot of people making excuses, and it's mainly fear. They don't want to do things in a different way. They don't want to stress themselves. They don't want to stretch themselves. They think it's going to cost them money. But in the long run, it's going to cost them longer because they're going to have to catch up anyway. And it's much better to turn early rather than turn late on these sort of things. The other thing is we have noticed a trait, and this has been within Oracle and within our client base, is this obsession for platform tuning. Bottom-up analysis, not actually looking at the big picture. Again, looking for the magic parameter to set. And really what has happened is we see there's a class of performance team or group or performance organizations where they're really happy with fiddling things outside the application because they don't control that bit or they have very little influence on the application. And they're happy to just try and fiddle around with the environment to make things better. And as a result, they just literally spend their whole life fiddling and measuring, and their goal setting in terms of performance improvement is not very high. And in many cases, we've actually found that the performance teams are the biggest obstacle to progress in terms of big picture performance gains. They find a lot of very often they're the buffer between us and the application developers and stop us getting through to them. They try to give a lot of procedural reasons why what we suggest cannot be done. Very often they say, well, that will involve changing code. And I'm like, too right. We need to change code because the code's not fast. So why not change it and give us a lot of basically what we call BS reasons and things. And really what we found out is that a lot of these performance teams are getting really uncomfortable when we come in because we're calling out the things that were big performance gains that they haven't found. And so we're actually finding in many cases that people with performance on their resume is actually the biggest problem to performance. So it's been quite interesting to see this. And usually we can isolate this by performance teams that are obsessed with running tests, measuring numbers, not necessarily getting to the root cause, and doing fiddling with things outside the main code line. And really, if you want to spend your whole life looking for marginal gains, you'll spend your life on platform tuning. If you want to be a real-world performance engineer, you're looking for the orders of magnitude gain, and you're going to have to start looking at code, application, logic, and seeing the whole problem holistically. And it's also a lot more fun. And it's also a lot more value. And it comes back to what we're seeing, what the real role of a real-world performance engineer is to initiate change. Change in performance by orders of magnitude. If we just wanted to increase things fractionally, we just sit around and let Moore's law do the work for us. And I think a lot of people have actually based their careers on just sitting around and letting Moore's law and CPUs speed up and then just migrate and making them look good. But really what I spend my time looking for is engineers that can make a big difference on the same piece of hardware. And so it's been an interesting trait we've seen over the last couple of weeks. Okay, again, the things we really ought to look at is people not looking at the algorithms for data management. And a lot of people are just, wanting to keep their head down, and politics and fear is upsetting people, or, not wanting to take risk and things like that. Performance is a risk-reward thing. If you don't make the changes, you won't go faster. The better you get at it, you're more likely to call out changes, and you can guarantee the performance gains. And the last thing I would really like to see eliminated from a lot of discussions is this performance by MBA type mindset, trying to cost justify performance increases. And really, always I hear this, people, is it's good enough for the business. If you were to increase the performance of your system by orders of magnitude, would you change the business? And this is where we can be innovative. And in many cases, I sit down and speak to application developers, and they say, oh, well, it's good enough. And I said, but don't you want to create truly innovative and pioneering products that are unique within your space? And they say, yes. I said, well, make it faster then. And so this is really the challenge. And I tend to find that I get dragged into a lot of meetings where there's a lot of talking and not a lot of doing. And I tend to cut these meetings short and say, what are we changing and what is our goals? And I recommend people start being a little bit more abrupt at these meetings to say, what are we trying to change and what are our end goals? And why do we think numerically that those changes will make a difference? Focus on engineering excellence. If you look at the pioneering work done by other engineering projects in the world, there was always a focus on excellence, and try and focus on that as much as possible. We're still collecting we're going to be opening up the website fairly soon to collect your real-world performance stories, so we can actually start looking at who's doing the best real-world performance in the real world, and gives you a chance to practice articulating numerically how you improve performance. And we're looking to in 2015 start really a catalog of really good real-world performance test cases in the field. Chance to show how your company is world-breaking, how you as an individual is doing great real-world performance, or a partner, how they've improved the performance of their products using real-world performance techniques. So at that point, we've got a few minutes left. That's what's been going on. I think we have another session in a couple of weeks. See, we've got a lot more participants this week than we did last week when I think it was Easter in Europe, and so everybody was on the beach. But if there's any questions coming up through the chat line, it would be great to see them. I did get some questions before the session, and I intentionally didn't really answer them because all of them were of a platform fiddling nature rather than a big picture real world performance. They all wanted to know what to set parameters or fiddle this or this type of stuff. And to be honest, the real world performance team is doing less and less of this, partly because we're now working on the same piece of hardware, i.e. an engineered system. And to be honest, there's very little to touch on that. And the big gains are going to be made at the application coding and correct use of the database level than just fiddling around with parameters. And so for those, unfortunately, who aren't working on engineered systems, you've still got a lot of system integration work to do. But again, are you just setting up the hardware such that you can get the best out of it? You aren't suddenly going to get an order of magnitude of performance out of a disk array if it's working at 90% capacity. It's not, you can't fiddle your way an order of magnitude faster. So try and keep things in perspective on that side of things. So I don't know if we've got any questions. It'd be great to hear some. I can see some familiar names out there. Good to see you all. And hopefully we can meet up in a few more weeks. And I'd like to make this much more of a two-way dialogue as time goes on.
window, Andrew. I apologize. This isn't my normal thing, so if there's something hiding out there that I'm missing, but I don't believe so. Are there any questions out there? Please, unmute yourself and feel free to use the voice chat to ask a question if you have one.
I don't see any questions at this point in time.
Thank you very much for your presentation. I know I certainly enjoyed it. In fact, it stirred up a lot of thoughts about similar discussions I've had with the coherence team and caching. So interesting to see the same things presented in a different light.
All right, I got some nice thank you messages. So if we don't get anything in about the next minute, I'm going to call it a day. And I think we're back in a couple more weeks. I'll advertise it via Twitter, and I'm sure Oracle Marketing will do the same. And again, if you need to send me or the Real World Performance Group an email with some questions and some topics you'd like, let's see how it goes.
All right, I'm going to, someone has mentioned that
really, we should be finishing up the video releases over the next month or so, and so that will be the completion of the videos that we have, and then over the summer we're going to be building more videos, more demos, and more material to embed at Open World and in the Real World Performance class and the Real World Performance Day. We have some interesting topics coming up for you, and that we're sort of fine-tuning in the field at this point in time, and we're looking to launch those at Open World and then into the real-world training from that point onwards. If there's things that you really would like to see us cover, again, we are fairly reactive. I kind of have to work by the rule of threes. If 3 people ask me for a topic independent of each other, we tend to get all over it because we recognize that there's a demand for that. So at that point in time, I'm going to say goodbye. To those in Europe, have a fantastic weekend. For those in Asia, have a good night's sleep. And for those in North America, it's Friday. Don't work too hard, and let's meet in a few weeks.
Very much. There are these presentations are recorded, this one included. I will shut down the recording in just a moment. There are a number of mechanisms that these are presented. Andrew mentioned a couple, Twitter, through official channels. This isn't my normal daily gig, so I don't know exactly how this presentation was sort of publicized, but I will see if we can find out and get this out to a broader audience. Thank you, everyone who attended, and thank you, Andrew, again. I'm going to stop the recording now, and I'll give everybody another minute or two if they think of a late-breaking question to feel free to ask it. Otherwise, have a, as Andrew said, have a great remainder of your day, evening, whatnot. Thanks all.